already up and running there. All right. Cool. All right, ready for you all too. Right. So, ladies and gents, good evening. Once again. So, let me just give a little rundown. So, we are. Hold on just now. Right, yeah. So, we here with me now on this screen. You can put our screen down. Thanks. Uh-huh. Right, yeah. So we are here on April the 2nd, right? For the rest of April, classes are usual days, usual times, right? Next week we have class Monday, Wednesday as per usual. The week after as per usual. On 21st is Easter Monday, no classes are public holiday, right? They'll have class the following Monday. Sorry, they'll have class the Wednesday, right? Now, the following Monday is when school starts back with the elections. I have no school that day. So we have class the Monday, the Wednesday, usual day and time. Now, after that, as you can see, I don't have your schedule until Tuesday after POE, right? So I'll pack up as many classes as I could, right? If you all have anything to do like EDPM, French, TD, HSB, you do your thing, come when you could, right? And of course, you don't have to come whole day because that'll be just very time consuming and very draining. But I'll be here facilitating, right? Right, yeah. Apart from that, yeah, and then of course, well, the maths, even Donovan, how are you doing? Good to have you on. Yeah, I was by your uncle today, trying to fix my wife's car. Get one thing done, but the rest of the stuff I do after. Anyhow, yeah, we were just showing them the only timetable for the rest of the month is basically classes per usual for all of April. And then for me, I don't know why it's doing this. Yeah, for me, I kind of pack all the up with plenty sessions from the Tuesday go forward, right? Because the exam is on the Friday, right? The Tuesday is POA, so that's one of my big exams in addition to maths. Is that pencil? Okay. Right. So yeah, so Donovan, so we packing up some sessions from the Tuesday evening come forward. And we have basically all day on Wednesday and Thursday. But of course, if you have other stuff to do, if you have any exams to sit, you do your thing, right? And then, like I was saying, down to the end, the multiple choice maths is the last exam, and it's on the 6th of June. So yeah, there's not very many weeks you'll have with this stuff. Sorry, say that again. Yeah, go ahead. What's up? Usual days, usual times. Yeah, Monday, Wednesday, 6:30 to 8:30. Mr. Fellman, good evening. How are you doing, sir? Good to see you on. Thanks for popping in and saying hi. Right. Sorry. More water. Yeah, guys. So, what was I saying? Yeah. So, of course, we'll organize some multiple choice math sessions in June. Yeah. Sorry. Will the crash course still be available for April 16th exams? Oh, sorry. The POA crash course. Right. Okay, sorry. It's actually two separate ones. Let me explain. So in the Easter break, I'm having the initial crash course on those in those 2 weeks, Monday to Thursday the first week, and then the 22nd, the Tuesday to Friday the next week. Right? That's the first crash course is 16 sessions. And then the following week is what I'm going to call the emergency crash course for anybody who couldn't make the first one. Right? As you can see, 2, 4, 6, 8, 10, 12, 14. And then somehow I had to give you all 2 more sessions on the Monday before the exam. But yeah, the crash course is still available. I was supposed to start marketing it since yesterday. That didn't happen. So yeah, if you want more details, just feel free to message me and I could organize. All right, so guys, sorry about the delay. So let's get back into what we were doing last time, which was coordinate geometry. Now, we did tackle a few questions, right? Right, so we did the May 2017 question, and I'm opting for the question with the graphs first because coordinate geometry is very graph based. Now, there will be questions where they give you no graphs. We'll get to those, but by the time we finish with these, you should be able to tackle those relatively easily. All right, so we looked at how to do the the gradient, right? We also looked at midpoint somewhere, and we also talked about perpendicular lines and the relationship between the gradients and the equation of a straight line. right? And then Jan 2019 again was another diagram, right? So we're gonna kind of continue, right? That's for POA. Yeah, that's for POA. Really behind me, I could still do a right POA. Yeah, I would say yes, Cash. The only thing I'll tell you is that I have no idea what comes on the exam. That's a mystery to me. They've been bringing very, very, very weird combinations of topics. Some of them have been kind of normal, some of them have been not. So I'm just gonna try and prep people for the things I think are going to come that usually kind of come, which don't really come anymore. That sounds confusing, I know. I apologize, but you can, but I can't promise, right? The multiple choice and the SBA would also help. So we'll see how we can do about that, right? Anyhow. Okay, guys, so let me find the next question we're doing real quick, and I'll copy and paste it. All right, so that's the 2016. No, I don't want that one. All right, so 2017 we did. 2018 doesn't have a diagram, so I'm gonna come back to that. We did 2019. Right, this also doesn't have a diagram. Okay, I like this one. This one is which one? Hold on, did I not see your next thing just now? No? Okay. All right, so this is the Jan 2020 exam. All right, cool. So let me copy and paste this real quick. All right, so Jan 2020. Right, insert, screen clipping. Okay, give me one sec. I want to see if I can copy and paste the other requirements. What is the gradient of L2? Oh, all right, so easiest questions again. Let me copy and paste it real quick, right? Insert screen clipping. Okay. And 1 second. So cut, and then still give me the line in between. Crap. Okay, we can work with that. All right, so ladies and gents, sorry. All right. All right, let's zoom in. Okay, sorry, I have to print this for you guys as well. Give me 1 sec. I'll print it from here. So 8 and 9. Okay, cool. All right. Okay, guys, so let's take a reading between in the meantime, right? While it's with the print here. So the graph below shows two straight lines, L1 and L2. So let's actually get some colors going there. Why does my display look different? Okay. So L1 in pink and L2 in green. All right, can we see those a little more clearly? All right, cool. Sorry. Right. Right. So L1 intercepts the x and y axes at 4, 0. Right. So the x axis, the intercept is here, 4, 0, and the y axis at 0, 2. So that's here. Right. So this one here is the x intercept. This one here is the y intercept. All right. Okay. Oh, did you all? Yeah, you all. Sorry, guys, give me 1 second. Only one copy printed. Quite annoying. This kind of annoying. Hurry up, hurry up. All right, current page. Okay, right. Hey guys, sorry about the delay. It's going to a little bit of a steel start. Okay, right. Now L2, they're telling us something about L2 here. L2 intercepts the x and y axis at 1.50. So that's here. Right? Here. And 0 minus 3, which is down here. All right, so we have those intercept points. Right? Okay. Now, what is the question asking us to do? Right? It says determine the equation of line L1. So line L1 is the pink line, right? And what did we use last week to determine the equation of a straight line? Right, so what, oops, hold on just now. Just now, give me 1 sec. It should pop back in. I know what happened here. I know what I had to do. Just give me 1 sec. It should pop back. Right, okay, cool. If it happens again, I'm just going to change the codes. Right, so y is equal to m by x plus c. But m is the gradient, and c is the y-intercept. Now, do we have either of those pieces of information given to us already? Hey, next, that's correct. Very good. What do we have? Y-intercept. Right, so we have the y-intercept. So what's the value of that? That's 2, right? That's the pink line. That's where it passes through the y-axis. That's the value of the y-intercept. So we know that that is already 2. But m is the gradient, right? Now we can't tell the value of the gradient just by looking at the line. We can get an idea of how steep or how not steep it is, how flat it is, right? But what's the formula for the gradient? That's the change in y, so y2 minus y1 divided by x2 minus x1. So we need 2 sets of coordinates. We need 2 points. And the thing is, we actually have, they gave us those 2 points already. They gave us the intercept points. Right? So we could actually use the 4, 0 and the 0, 2. You don't have to go and read off any more points. Right? But you could if you want, right? So you could use 4, 0, which is, again, this point right here. And then 0, 2, which is this point right here. Right? Now, of course, if you're feeling adventurous, you can read off any other pair of points on the line. For example, right, you may say, okay, look, look, this point right here, gives us minus 2 on the x and 3 on the y. This is minus 4 on the x and 4 on the y. Minus 6 on the x and 5 on the y. Minus 8 on the x and 6 on the y. Any of those, even this one, you could use 2 on the x and 1 on the y. You could use 6 on the x and minus 1 on the y. So any of those points, any of those pairs, right? Okay, but sometimes it's nice to use the easy things that they kind of give to you. Right, so you could do x1, y1, x2, y2. Right, so y2 minus y1 is 2 minus 0, and x2 minus x1 is 0 minus 4. Right, so what do we have? 2 minus 0 is 2, 0 minus 4 is minus 4, and 2 over minus 4 is simply minus 1/2. And now we can use that value for the gradient in conjunction with the y-intercept and the equation of the line, y equal to m by x plus c. So y is equal to m, which is minus 1/2, then by x plus c, which is 2. All right, cool. All right, cool. All right, D'Angelo, Donovan, and Noah, just give me a quick G in the chat if you give it that, please. If you have any questions, please feel free to let me know. Not a problem. D'Angelo here, Donovan here. Juliana said she couldn't come today. Hanifa here, Jean here. All right, I'll take out Janaya. Javi, I know we're not Javi. All right, just Yuri here. Julie is here. Khalifa wants to do sick. ISC and Liam. Logan. Noah and Ella Page. Zian's mom said he was supposed to start back, so I don't know where on there. Right. Oh, hey Lilian, how are you doing? Okay, cool. So, ladies, are you okay with the equation there? All right. Now, the next piece, right, says what is the gradient of L2 given that these two lines are mutually perpendicular? Now, we said before that perpendicular lines meet at what angle? They meet at a right angle. Right? And we said that there's a specific relationship between the gradients of those two lines. Right? Right? So the gradients, when two lines are mutually perpendicular, right? The product of their gradient. So let's say the gradient of line 1 was m1 and the gradient of line 2 was m2. When we multiply those two gradients together, we get minus 1. So if we have the value of this gradient and you want to find this one, given this relationship, what would you do? Right? You're trying to make this, you're trying to solve for this, make this the subject of the formula. Yeah, correct. You have to kind of move this across to the next side or remove it from the left side. It's connected by multiplication. And to remove something attached to multiplication, we use the opposite operation, which is division. All right. So we know the value of the gradient of line L1 is minus a half. Right? So basically what we're saying here is M2 would be equal to minus 1 divided by minus a half. Okay, cool. Now, what's the protocol when you're dividing fractions? You change divisor and you invert the divisor. So now it's minus 2 over 1. And a minus multiplied by a minus is a plus. So the gradient here would be positive 2. Now, I have an extra piece to add on here for you that the question isn't asking for, but I'm giving to you as extra practice. I want you now to state the equation of line L2, right? So we know the equation of line is y equal to mx plus c. So we need what? We need the gradient and the y-intercept, not so? We just found the gradient, which is what? No. Yeah, right? When we divided and multiplied, right? Sorry, when we divided the fraction, we got 2, right? And we also need the y-intercept. So line L2 is the green line. Can we see the value of the intercept on the graph there? The green line, the y-intercept? On your page? Right. What is the value of the y-intercept? What two numbers is it between? Or you can look at the top of the page and look in the sentence and they'll tell you what the y-intercept is. No, look at the top of your page in the little sentences they give you. And I'm going to tell you about line L2, about the intercepts. Right, so 1.5 and 0, that's the x-intercept because you have an x value, that's not 0. And a y value of 0. And for the y-intercept, the x value would be 0, but your y value wouldn't be 0. So what is so negative 3. And again, if you look at the graph here, the green line is passing through negative 3. So the negative 3 isn't stated explicitly, but it's between negative 2 and negative 4. So the y-intercept value is minus 3. All right, so the equation, yo. I'm seeing literally for one of these questions. This is from Jan 2018. For one of the questions, you had to break up into certs to get your answers. So there's supposed to have certs. They don't certs. Okay, based on what Kirk told me, he said technically there, but it's not really. Okay. So. I'm looking at this and only have no regular person just doing math. No. But and they've never brought it back since. They never brought, yeah. You know the question I'm talking about. Yeah. Yeah, this is insane. They also did something like that in either the Jan 2019 or Jan 2021 paper, where they had a circle and they had a square in the circle, and and basically you had to find like there was a hypotenuse in the circle, and to find it basically you had to, and the way you wanted to express it was in circle. Yeah. Right. Okay, right. So once again, the equation of line L2, right? Again, it's a straight line as a green line given by y equal to mx plus c. And given what we just saw up here with the equation of a straight line being y equal to mx plus c, where m is the gradient and c is the intercept, the y-intercept to be specific, right? So that's why in part two here in the green, they asked us what is the gradient of line L2, given that line L1, the pink, and the green line are perpendicular. And like I said, we know that the relationship between the gradients of perpendicular lines is that their product, when you multiply them together, you get -1. So if we know the value of one of them, which we know from on top of here, -1/2, we can say, okay, look, all we have to do is divide by the value we have on both sides of the equation. So it'll be -1 divided by that gradient. And of course, when you divide them by fractions, you change divide to multiply, and you invert the divisor. And when you multiply a minus by a minus, you get a plus. So that's the value of the gradient. And then the y-intercept, so two things. You could have seen it on top of here, where they told it us, or you could look at your graph, right, and see that, hey, it's right there, -3. So we didn't have to work out anything extra, right? Okay. All right, cool. Okay, ladies, are you okay with that? Do you have any lingering questions? Anyone want to re-explain? Are you okay? All right. Okay, so D'Angelo, Donovan, and the one, just give me a quick G in the chat if you're good with that. If you need me to re-explain anything, let me know. It's not a problem. Sorry. All right. Cool. Okay, cool. So that's the Jan 2020 question. Let's put that one down. Let's go back to the PDF. All right, so we did the part two. All right. We'll come back to the questions that have no diagrams and talk about them after. Oh, right. Okay, hold on 1 second. That's the 2021. Okay. All right, so I had to copy two pieces. Do I? Hold on. Yes, no. I have an idea. Oh no, it's not gonna work. Okay, it's not gonna work. Sorry, I'm gonna just have to copy and paste separately. Okay, so this is May, June 2021. All right. Come back here. All right. So let's go here. This is May 2021. First exam after the pandemic. We had to go in. Oh, so sorry. First paper 2. No, I lied. The Jan 2021. You had to go in. Yeah. That seems so far away now. It's kind of unreal. Right. Give me a couple of seconds. I'm just going to copy and paste the other pieces. Right. Insert. One. Right. So just space in between. Delete this as well. Right. And then just one more piece. Nope. Maybe just print this one. Why not? Might be easier. All right, cool. So this one has a graph, but a little different. So we'll take a swing. All right, guys, so let's take a read of the question. So it's May 2021. So the diagram below shows two lines, L1 and L2. So again, let's get some colors going there. Give me 1 second. One. Pink and green. Okay, it seems pretty visible. All right, let's take a read. So the equation of line L1 is x plus 2y is 10, which I gave us here. Now, what do you notice about that equation? It's not in the form y equal to mx plus c. It's in a different form, right? But we could put it in the form y equal to mx plus c if necessary. And then that's the pink line. The green line, L2, passes through the point 0, minus 5 and is, what's that word there? Perpendicular to L1. What did we just see about the, sorry, what did we see in the previous question about perpendicular lines, apart from they meet at 90 degrees? Right, so they meet at 90 degrees, and there's a relationship between their gradients. The product of their gradients is minus 1. We saw that here just now. When two lines are perpendicular, the product of their gradients is minus 1. So when you multiply the gradients together, they get minus 1. All right. So they want us to find a few things, right? So the first thing they do is they want us to express the equation of line L1 in the form y equal to mx plus c. So right now, line L1, the equation is in this form. X plus 2y is 10. And they want it in this form, right? Then they want the gradient of line L1 and then the equation of line L2. So I'm going to give you guys a couple of minutes to take a little head start. If you're not sure what to do, you can say, because I'll ask a question, no problem. But y'all have to try the question, all right? If you're not sure what to do, that's okay. Ask, all right? The first thing you're doing is you put in this in the form y equal to mx plus c. Right, so the first thing is you shift across the x from one side to the next, right? Okay, how is the x connected on the left-hand side? What operation? Does it multiply between the x and the 2y? So to remove something, so you'll subtract it from both sides. That's correct. So it'll be minus x plus 10, right? As opposed to 10 minus x, because they wanted in the form y equal to mx plus c. So they want the x term before the constant, right? And the 10 is the constant because it's a 10, right? There's no variable, no algebraic term attached to it. So the value can't change. Hence it's called a constant. Oh, hi everybody, TikTok. I don't know, Nico was here last week. Others who are casting. Evening, everybody. All right, so let's go in there. Okay, so first things first, you want to move the x. How is the x attached on the left-hand side? Addition. So to remove something attached by addition, subtraction, right? That's tomorrow. What you get through, Kev? Evening, Joseph, for vibes. Right. Who's that? Kira. Hey, Kira, good night to you. Right, so the first thing we're going to do is we're going to minus x from both sides. So when you minus x from this side, it'll cancel, leaving us with just 2y. They could have 10 minus x, right? Now, again, they want it in this form. So they want the algebra in front or to the left of the constants, right? Sorry. So what we're going to do, we'll just restate this as 2y is equal to, equal to minus x plus 10, right? These two lines mean the same thing. Okay. Now, how is the 2 attached to the y? Yeah, 2y is 2 multiplied by y. So how do we therefore remove something attached by multiplication? We use division. Very good. So we use divide by 2. So when we divide by 2 here, it'll cancel, leaving us with just the y. And of course, whatever happens on one side of an equation must, right? So we'll divide everything. Now you could do it in one of two ways. You could divide everything by the 2, which will just turn to each item being divided by 2. Sorry. How's your school, Ayla? How's your school? FL? Not surprising. I think she just hasn't found her people. She has to go somewhere to find her people. Huh? You minus the 2 from the 10. No, you wouldn't minus it. You would actually divide because the 2 is connected by multiplication on that side. So when you shift it across, you have to use the opposite operation. And the opposite of multiplication is division. All right, so hope that helps. Right, now 10 divided by 2, as you correctly said, Julie, is 5. And minus x over 2 is the same as minus a half x. Right, because minus a half x, what was the understood operation between minus a half and the x? Multiply. So if you multiply like this, you'll end up getting minus x over 2. So this and this mean the same thing. Right? So now, this is in the form y equal to mx plus c. Right? So this here is your answer. Right? Now, you don't have to draw a rectangle around it or right answer, but that was something that they taught me. They told me to underline it and put ANS for answer. Although your working attracts more the marks than the answer, but you still get a mark or a half mark for the answer. So you want to make it easy for the examiner to find and give the marks. Sorry, thank you. Okay. Ladies, are we okay with that? You okay then? All right, Donovan, D'Angelo, and Noah. You say my quick G in the chat if you're good with that. See that. Cool. All right. Okay, the next thing says state the gradient of line L1. So this is the equation of line L1. So based on this equation, what value would be the gradient? Minus a half, because the gradient is the coefficient of the x term when it's in that particular format. All right. Now, the last thing they ask, oh, sorry, that was entirely the wrong place. Right. Now they said, hence determine the equation of line L2. Now, how are we going to do that? Now, the line L2, right, from the diagram above, is the green line. So, quick question, is it a straight line? Yes, right? What is the equation of a straight line? Y equal to m by x plus c. Now, m is the what? M is the gradient. And c is the, very good. Now, do we have either of those pieces of information on the diagram? Yes. Which one? The y-intercept. And the value of the y-intercept is minus 5, right? Now, the gradient. We saw previously, right? The gradient, as we know, has a formula, but we need 2 points, 2 sets of coordinates. Right now, we only have 1. We don't have any other sets of coordinates for anything else, right? Right? We had to kind of find it for L1, right? So we know L1 that this value across here is 10. And how we know that? Because, sorry, it's 5, not 10, it's 5. Sorry, it's 5. And we know that because when we found y equal to mx plus c, the 5 was in the same position as the c. So the 5, sorry, I'm talking utter rubbish. Why is that rubbish? Because this is the what axis? The x-axis. And the c is the y-intercept. So this value here would be, wow, sorry guys, my brain. It didn't brain properly. Okay, so next question. How do we then therefore go about finding the gradient of, right, because as it says in yellow there, the 2 lines are perpendicular, which means they meet at a right angle. And as Jolie is saying, it also means that the product of their gradients, if you multiply the gradients of those 2 lines together, you get minus 1. Right? Now we have the value. We have the value of the gradient, which is minus half. Wasn't that the same value from just now? It was also minus half in the previous question, not so? Yeah. Right. So we know that this value here is minus a half. And we multiply it by the gradient of line 2 to get minus 1. So how do we therefore find the gradient of line 2? We'll divide by minus a half on both sides, right? So minus 1 divided by minus half. And of course, when they divide them by fractions, the protocol, they change divisor, multiply, and invert the divisor. And of course, when you multiply minus by minus, you get a positive. So the gradient is 2, and the y-intercept is minus 5. So we could simply state the equation. We're putting that boy. Okay. So the equation, therefore, is y equal to m, which is 2 by x. What was the intercept? Minus 5? Right. So once again, we use the graph, right, to get the y-intercept. They gave it to us there. Actually, they gave it to us here as well, right? But yeah, of course, have to know how to interpret the question. And then to find the gradient, we use the fact that the two lines were perpendicular to each other, mutually perpendicular, and we had the gradient of the other line, which was minus a half. Ooh, what is that now? All right. Okay. All right. So Deanna, John, if you guys are good with that, give me a quick genie chat. No, we're going, boy. No, we're going. Like, nah, go with this. All right. Ladies, you okay with that? All right, cool. TikTok, how we feeling there? 18 what? Alicia, Mara, not sure. Okay. All right, we okay with this one? Okay. Try the next one. Okay. Give me a couple of seconds to print out for the ladies in class. There's just two of them here. And I'll copy and paste the diagram and questions shortly, right? All right. So yeah, it's a little, as you can see, the paper didn't come that good that year. It's kind of curved. Right, but we'll see. Oh, sorry. This is what it is made 2022. All right, cool. So there we go. Let's go here. Copy and paste. Right, you go there. I gotta print out a few things well for the next page. Let me check the next page real quick. Yeah. Um. Okay. You know what? Instead of just studying, let me just start copying and pasting. Right. So here. All right. So insert. Screen clip in. That's protocol. That's protocol. For all exams. Yeah. All schools. You can leave. Yeah. Uh huh. Invigilators. Uh huh. School could do that. That- I didn't realize that. Yeah. So here's a question: what happens if you just walk out anyway? What they gonna do? Buy it for the rest of the exam? I mean, I don't want to. I don't want anybody to find the hardware. Yeah. What they gonna do? Hold on to it physically? That not gonna happen. All right. Okay, cool. I think we're ready there. Thanks for your patience, guys. I know all this should have been done before, but my days are not my own most of the times. That just sounds like a question. Hey, Peter, how you doing? I don't like saying that statement. Well, I'm not sure. It has to be a minute. Hey, yo. Right, so ladies, yeah, ladies are ready for you. Hello, hi, this screen here. Okay, so it says, oh, sorry, I didn't give you a question. My bad. Okay, let's go. So the line L1 is shown in the grid below. So that's line L1. Let's give it a nice little color. So So write the equation of line 1 in that form. Right. So they want it in that form. So we need the gradient and the intercept, or the y-intercept. Do we have the y-intercept? 1, right. Do we have any other point along the line? Yeah, we could read it off. Look here. If you take this point here, you can read down, you get 3 on the x and 2 on the y. If you take this one here, you get 6 on the x and 3 on the y. Right? Now I'll give you a little hack you could use, right? So you see like how I was able to get points where I had whole numbers on both the x and the y? Right. Now, what is the gradient? The gradient is the change in y divided by the change in x. Not so? Okay, cool. So to move from this first point here to this point here, how much did the y change? It went up from 2 to 3, which is what? An increase of how much? 1, right? And the corresponding increase in x was that to go from 3 to 6, which is a jump of how much? That's 3. And there you go. That's the gradient, right? Now, what I'd like you to do is just to confirm it. I wanted to use the y-intercept and the x-intercept because they gave you those, right? So the y-intercept has coordinates what? That's 0 and 1. And the x-intercept has coordinates -3 and 0. So if we do that, okay, yeah, so yeah. So I wanted to use the regular gradient formula and those two coordinates, those 2 points, right? So y2 minus y1 all over x2 minus x1. Is that Hall and Mass crew? Peoples? Carnival 2020. Last time I played Mass. 1,000 likes, boy. Wow. Yeah, accounts at 3,700. The cool time. This is just 45 minutes. Good. Interesting. Right. Thanks very much. I have a name. With the sideways profile picture. Right, mini 17. Oh yeah, you're welcome. Right, are we okay with the gradient of 1/3? Right, so when we put it together with the y-intercept of 1, what is the equation of that line? Very good, right? So y is equal to 1/3 x plus 1. Right, cool. All right, cool. Donovan and Dion, just give me a quick G if you give me that first piece, please. All right, cool. All right, now let's take a look here. The equation of a different line, Q, is y is equal to minus 2x plus 8. Right, so it says write down the coordinates. Hold on 1 second. Yeah, this one. Right. Of the point where Q crosses the x-axis. Right. And then write down the coordinates where it crosses the y-axis. That's the easier one. Where it crosses the y-axis is called the y-intercept. And we know if we have the equation of the line in the form y equal to mx plus c, this value here is automatically the y-intercept. Right? So the coordinates, you're correct in saying that the coordinates would be 0 on the x and 8 on the y. Right? Now, for the x-intercept, for the x, so for the y-intercept, the x-coordinate is 0 and the y-coordinate is not 0. Right? Now, it could be, but that's a certain specific line, right? Right, sorry. Now, for the where it crosses the y-axis, sorry, the x-axis, that's called the x-intercept. And in that particular case, what would happen is that the x value would usually be a non-zero, but the y would be 0. Right? So to find that point, the x value, the x coordinate of that point, what you have to do is put y equal to 0. Right? So if y is equal to minus 2x plus 8, to find the x coordinate, put y equal to 0 and then solve for x. So I'll give you a minute or two to do that. Right? Oh, okay, cool. Right, minus 4. There you go. Right. Right. Okay, cool. So the first thing we could do here, you have different ways you could approach it. How did you all approach it? Just divide what by what? Okay, so you divide everything by negative 2. Okay, cool. So we could do that. We could divide everything by negative 2. Sorry. So 0 divided by anything is still 0, right? Now, minus 2 will cancel with minus 2 between the numerator and the denominator, giving us with x, not so? And of course, 8 divided by minus 2 will give us minus 4. And just by looking at this statement, right? If x minus 4 is 0, so they say that some number, when you subtract 4 from it, you're left with 0. There's only one number you can subtract 4 from and get 0. What number is that? 4. Right? So therefore, x would be equal to 4. So this value here, right, is 4. Right, so it's not really were close. We were close. I think you just forgot to carry it over to the next side of the equal sign. All right. Now it says on the grid on page 14, draw the graph of that line Q. All right. You got 4? All right, cool. Right. So we need 2 points to draw a line. And what did they have us do in the first two pieces of the question here? They had us get the intercepts. So all you have to do is plot those 2 points and draw a straight line through them. So you're going to plot 4, 0 and 0, 8. Right. Oh, you're wondering? Okay. Yeah, no problems. Right. So 4, 0 and 0, 8. 4, 0 and 0, 8. Right. Okay. Let's put that. So 4, 0 would be here. And then 0, 8 would be here. Right. And what we'll do is we'll draw a line straight through them. Wow. Okay. That did not go according to plan at all. Okay. Well. No, 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 no. No, 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 no. All right. You all got something looking like that? With the green line? All right. Visible? Okay. It looks visible enough. Okay. And the last piece, according to the graph, the solution of the system of equations consisting of L and Q is, okay, so we encountered this last week. What was the week before? Right. When you have simultaneous equations, you can solve it in multiple ways. You could use elimination, substitution, and it could be graphical. And when you do graphical method, you end up with two, well, if assuming you're using linear equations like this, right? So where the lines intersect is the solution, right? And the lines intersect right here. That's correct. And the, what you call it, the coordinates there are 3 on the x and 2 on the y. So that is the solution to the system of equations L and Q, right? So x equal to 3 and y equal to 2. Right? So once again, if you have simultaneous equations and you graph them where the lines intersect, right, which is that the purple circle there, where the green line and the pink line overlap or intersect, that is the solution, right? They both occupy the same space, same point in space, I should say. Okay, Donovan and D'Angelo, you all okay with this bottom half of it, I guess you could say. Let's give them a quick G, please, sometimes. Ladies, are we okay with that? All right, cool. All right, lovely. That's 2022. Let's see what else they have. Oh, 2023. Front page. So I'm gonna copy and paste this stuff. Jan 2020. Hold on, what paper is it? Jan 2023. Okay, cool. Sorry. Do I want to copy all four, or can I just copy that one? I wonder, boy. Actually, you know what? Hold on. Let me see. I wonder if I can do that. I'm gonna go here. Right. Let me hold on. Sorry, give me one. Give yourself. Right. All right. Think I know what I want to do here. Right. Okay. Well, it didn't come out as I would have liked it to have come out, but all right. Okay. All right. Let's see if this particular one was right. 99. With more than 10 friends. Wow, that's amazing. Thanks very much. Everybody else too. Okay, so did I give you guys here? No, I didn't. Right, so Jan 2023. Let's take a look and see what. 505. Wow, that's pretty cool. Right, so lines L and M are drawn on a square grid below. Okay, hold on. Right. Paste. Oh, that's now. What did I do? Right, okay. So let's get some colors going here, but they have the usual questions they ask. That look, actually, I think I'll go a little heavier on that line. All right, that's fine. Yeah, okay, that helps. Right, so write down the coordinates of the x-intercept of line L and the y-intercept of line M. Right, so go ahead. So now it's math. Yeah, yeah, so 46 is the POA, and then half 6 and half 8 is math. sorry. Right. So your line L, y-intercept is 6. Right. So line L, right. So that actually is the x-axis you're looking at there. Yes, 3 is correct. Right. That is the y-axis, right? Okay, cool. How do you find the x? Well, the x-intercept is where it cuts the x-axis. So the pink line cuts the x-axis at the point where x is equal to 6. So that's the x-intercept. Y-intercept is the point where it cuts the y-axis, right? So the x-intercept of L. Oh no, you were right. It is 6. No, sorry. Line L, they want the x-intercept. So the x-intercept, right? So and they want the coordinates. So that's 6, 0, right? And for the green line, the y-intercept is the point where it cuts the y-axis. So that's 0 and minus 2. Hey, Harmony, thanks very much. Okay, cool. Okay. So the equation of line L, pink line, is x plus 2y minus 6 equal to 0. Find the value of k given that the point 9k lies on line L. Okay, so they've given us this item here, which is the equation of the line, but it's not in the usual form, right? Now, you have a couple different ways you can handle this. So one way is you could put it in the form y equal to mx plus c. Now, the 9 is the x coordinate and the k is the y coordinate. All right. So you could, so right now, as a matter of fact, you could actually plug the x inside of here and simplify and solve for the value. So let's try that, right? Let's try that. So we're going to replace the x with a 9 plus 2y minus 6 is 0. Okay, I'm going to give you a minute. Sorry? K? Okay, you can do that. Yeah, that makes sense actually. Thank you, Hanifa. That makes sense because, yeah, we're looking for the value of k, right? You're most correct. That's correct. All right. All right, let's take a look. Right, so we can rearrange here and do 9 minus 6 plus 2k is 0. 9 minus 6 is 3. Now, you could also write this as 2k plus 3. Now, if you want to solve for the value of k, we want to remove everything currently attached to it. So let's start with the 3. I know, yeah? So how is the 3 attached to the k? What operation? How do we remove something and therefore attached? By using subtraction. Very good. So 2k from who? Okay, cool. And of course, whatever happens to one side must happen in the next side. So of course, 3 minus 3 will cancel the 0, leaving us with just 2k here, right? And 0 minus 3 is minus 3. And the last thing to happen is you have to remove the 2. How is the 2 attached to the k? And to remove something attached by multiplication, we have to use division, right? So we'll divide by 2k, right? And of course, whatever happens on one side of an equation must happen on the next side. So 2 will cancel with that numerator and denominator, and we have minus 3 over 2. You gotta trust yourself, you know. She's not gonna be anything to help you out. Okay. All right. Now they want you to find the equation of line M, right? In the form y equal to mx plus c. Okay, so line M is the green line. So we need the what? The gradient and the y-intercept. Now we have the y-intercept already, which is minus 2. So all we need is the gradient. Right? Now, I'm willing to bet that these two lines end up being perpendicular, but they didn't tell you that outright, so you can't assume. So what we're going to need to do is we're going to need to use 2 points to find the gradient. So what I could strongly suggest is to use the y-intercept and the x-intercept. Right? You could always use that point and that point there if you want, but you don't have to. Sometimes the intercept points at you. So what I'd like you to do is find the gradient, and then using that in conjunction with the y-intercept, state the equation of line M in the form y equal to mx plus c. Any 2 points on the same line, yeah. Wouldn't matter which points you use, they'll all give you the same gradient. All right, sorry. Another day, another sleep. I like that one. So they told us to explain why yeah, trying to neaten this up. I have this 5 is I can't get master the art of the man, but if I learn that I might be able to keep it long. Late? That's all right. We have about half an hour again, so I mean, better late than never. That's 3. That's all. Right. So do you stop the 6 account slides? No, I had one today. I had my CCA class live today, 46. I didn't do any class Monday because Monday was a holiday in Trinidad. Yeah, so the last time I had class was last week, Wednesday for PUA. All right. Jaden. Oh. All right. All right. Well, safe drive. Yeah. Ernie, thank you. Click one of the straight A profile, Jaden. That's awesome. If it's still there, that'd be great. If you can DM on like Instagram, I'd love to chat about that to see how it helped. Because I'm trying to get some feedback and refine my process to make it a little better or see what works and we can do more of that. So that would be that'd be great. Thanks very much. If you're not there, well, my bad. Right. Karma. Your account will oh Chase Edred. Thanks. Thanks very much, guys. I appreciate that. Yeah. I haven't been able to make money because I have 2 young kids. I have a 5-month-old. Yeah. Yo. 100,000 centimeters make up 1 kilometer. Yeah. Yeah, so I have a 2.5-year-old and I have a stepson in SCA this year. So the production has not been growing that well. But I'm trying to do some shorts for them. And some vertical content too. But thanks for watching this stuff. I appreciate it. Right. So let's get that done. So it was 1 0 and minus 2 0. Okay, cool. Let's see if you could. Right. How come? Okay. What's your preferred medium then? What platform you prefer to communicate on? Yeah, WhatsApp is nice. I like WhatsApp too. Great tutor. Oh, thanks very much. I still don't know your name, so I'd like to thank you. Yeah. Right. Okay. Right. Okay. Cool. So, to find the gradient, so m, right? So x1, y1, x2, y2. M is equal to y2 minus y1 over x2 minus x1. That's minus 2 minus 0, and then 0 minus 1. So we'll get minus 2 over minus 1, which just gives a plain old value of 2. Right? So now the equation of the straight line is y is equal to m by x plus c, where m is the gradient and c is the y-intercept. So this will simply be y equal to 2x minus 2. Gradient. Very good. All right. Okay. Donovan and Dion, just give me a quick G if you guys give it these two things that are currently visible. Please and thanks. Very good. Thank you. All right. Can't comment. Oh, well, you don't know if you could or you can't. Go over it. Okay, it would. Okay, cool. All right. Okay. That's Mandy. Okay, so Mandy. They're asking us to find the equation of this line in this form y equal to mx plus c, right? Sorry, one sec. Right. Now m is what we call the gradient, and c is what we call the y-intercept. If we go to the graph, right, this, hold on. Let's clean up a little bit, sorry. Give me a sec. Give yourself a man, right? Sorry, Mandy, give me, right. So this point here, point 2, is the point through which the green line is going through the y-axis. So that's called the y-intercept, and the y value there is minus 2. Right? So that actually kind of saves off some weekend. Right? A B. Right. And now to find the gradient, we need 2 points on the line. Right? So we could use this other point here, which happens to be the x-intercept. Right? And that has a x value of 1 and a y value of 0. The y value is 0 because it's on the x-axis. And at every point on the x-axis, y is equal to 0. Just like at every point on the y-axis, x equal to 0. Right? So on the x-axis, y is 0. On the y-axis, x is 0. Right. So like I was saying, we have 1, 0, and 0 minus 2. Right? And we put that into this formula here. Right. Okay, Kadisha. So, huh? Yeah, she did. Yeah. So next week then. The last day or today? Okay, cool. All right. Yeah, see freedom. Right. Right. So yeah. So now when you plug in those values, so y2 minus y1 is here, minus 2 minus 0. And then in the denominator is x2 minus x1. 0 minus 1. So minus 2 minus 0 is minus 2. 0 minus 1 is minus 1. And when we divide a negative by a negative, we get a positive. Right? What question on the paper is this? That's a good question, boy. Give me 1 sec. I'll tell you just now. This was question 4 on the paper. All right. All right, cool. Yeah, so okay, you guys going? All right. All right. So no PUA tomorrow, we done. But you guys have anything going on in PUA that you need help with? And yeah, then be good. If you need any help, message me. It's no problem. All right. All right, Chrissy, well, enjoy your outing tomorrow. Be safe. All right, later. Bye. Cool. Okay. Ladies, we okay with the answer here? All right. Now it says show by calculation that line L and line M are perpendicular. Now when two lines are perpendicular, there's a relationship between the gradient, which is what? The product of the gradient is? Right? When you multiply them, the value you get is? Good. So we have to take the gradient of, hold on, what are the lines again? Oh, okay, so gradient 1 multiplied by gradient 2 should give us minus 1. So this is what we have to be able to prove, that the product of the gradients is minus 1. Now, we just found the equation of, this is M, right? This is line M, big M. And do we have the equation of line? Yeah, we do. But they give us in this form here. So we have to convert that to the form y equal to mx plus c. So if we start at x plus 2y minus 6 is 0. All right, so Omni guy. Oh, yes, thanks very much. Yeah. Yeah, so we have to convert this into the form y equal to mx plus c. All right, so I'll give you a minute to sort out. You want to move everything onto the next side, away from the y. I'm a professor in college. No, I'm not. Like a professor has to have a doctorate. I have a very humble and meager BSc, bachelor's. I don't even have a master's. I used to teach in a school called Fatima College, but that's not a university. All right, so first things first, let's carry across the x and the minus 6, right? Okay, so let's see. So we have minus x and plus 6. And then we'd have to divide by 2 to get rid of 2, right? So of course, when you pull the x out, I don't have a doctorate to sell. I barely have a first degree as far as I'm concerned, yes? And 6 divided by 2 is 3. Right, so this is the equation of line L. Right, this is the value of the gradient. M is equal to minus a half. Right? And the gradient here is 2. Right? So if we simply show that we have minus a half for the gradient of L and multiplied by positive 2 for the gradient of M, right? 2 will cancel with 2 once, 2 into 2 once again, and a minus by a minus, sorry, a minus by a plus is simply a minus. And there you go. Oh, sorry. Right. Go over. All right, cool. All right, so that's, is it Chase? Chase the correct thing? All right, Chase. They wanted to show by calculation that the lines are perpendicular. What perpendicular means is that the lines, when they cross or overlap, the angle formed, sorry, let me change the weight on that point. Yeah, the angle so formed is actually 90 degrees, right? That's what it means for two lines to be mutually perpendicular. And when two lines are mutually perpendicular, there's a relationship between their gradients, right? Now, the gradient is usually denoted as small m, right? So if you take the gradients of the two lines and you multiply them together, you're supposed to get minus 1. And that proves that they are perpendicular, mutually perpendicular, right? So what we had to do is get the gradients for the lines. Now, in the previous part of the question, part C, we had to find the equation of line. Sorry. Yeah. We had to find the equation of line M. And in so doing, we calculated the gradient as 2. Right? So the green line had a gradient of 2. Okay? And then the pink line, they gave us the equation in this form. But we can't extract the gradient from that in this form. We have to convert it to the form y equal to m by x plus c. Because when we do that, are you all warm or something? Right? Sorry, the gradient is the coefficient of the x2. So what we did is we took the item in yellow, right here, and we expressed it, in this form, which is in the form y equal to mx plus c, right? Which means we're simply making y the subject of the formula. So in so doing, right, we had to quote unquote carry the 6 across and carry the x across. Right? When you do so, you use the opposite signs to do that. So x was positive here, so when it goes across, right, it'll be a negative. And if 6 was negative, when it goes across, it becomes positive, right? But that's not the best way to explain that, but it'll work for now. So 2y ends up being minus x plus 6. And then to solve for, and again, to solve for y, to make y the subject, you have to remove the 2, right? The 2 is attached by multiplication. To remove something attached by multiplication, you have to use the opposite operation. And the opposite of multiplication is division. So what would happen is we would divide by 2 on both sides of the equation, right? So 2 divided by 2 will cancel. So 1, leaving us with just the y. And here we'd express each aspect of the numerator separately over the common denominator, or as I say, decompose the fraction. So you get minus x over 2 and then 6 over 2. Right? Minus x over 2 is the same as minus a half x, minus a half by x, right? Because when you multiply fractions, you're going to multiply numerators together and then denominators, right? So minus a half x is the same as minus x over 2. All right? Right? And of course, 6 over 2 is just going to give us 3. But what we are more interested in is this piece here. That's the gradient. So we took that gradient, minus a half, and the gradient of 2 down here. And when you multiply them, you get minus 1. And that's how we prove that the lines are perpendicular, right? Showed by calculation. All right. Okay, sorry, last part now. Line L and line M represent the graph of a pair of simultaneous, oh my lord, equations. All right? Using the graph, write down the solution of the pair of simultaneous equations. Now, from the previous question, what did we say we have to do when the lines intersect or overlap? So all we'll do is we'll go to the graph and we will identify, right, the point where the overlap, which is there. When you read down to the x, you get 2, and across to the y, you get 2. So x equal to 2 and y equal to 2. All right, Donovan and Diane. So just give me a quick Genie chat if you guys good with that solution. Please answer. Thank you. Hey, Pooja, how you doing? 100 likes, wow. And 21 people watching and 21 following. Wow, guys, that's amazing. Thanks very much. All right, Chase, I hope that helped. If not, sorry, I had to move on. Kind of pressed for time. Hey, Chocolate Leo, how you doing? Yeah, I'm for myself. Wow, that's pretty cool. Thanks for sharing. Okay, cool. Right. Let's put that down. That was the Jan 2023. All right, cool. June 2023. Okay, I think I put the wrong paper, the wrong thing there. All right, this is Jan 2024. Okay. Jan 2024. What is good? Hey, I clicked there. I didn't click the other place. Okay, It did. Okay, glad. Glad to hear that. Right. You guys, give me a couple of seconds here just to put in the values in there, right? Right. We'll do them one at a time. What? Okay, cool. Right, let me print the two copies of the girls here, and then we'll go from there, right? All right, and we'll zoom in, see what they're asking us for. Right, diagram below, two pairs, right? Two functions on the same pair of axes. We have G, which is the pink line, and we have H, right? And look, to tell you outright, the lines G and H are perpendicular. And they actually give us they give us the perpendicular 90-degree angle symbol there. All right, cool. Right. Okay, so they want the equation for G, the equation for H, and the coordinates of P. Right, so I'll give it all a couple minutes to sort that out. They want the equation of G, the equation of H, and the coordinates of P. This one a little different, eh? So I'll give you a couple minutes to take a read, try a thing, right? Because you gotta try.
From Jan. Oh gosh, sorry, June.
Okay. Okay. Yeah. Wait, you mean Monday? Today's Wednesday.
Oh, is she having these meetings throughout the week? Then now today. Is it cool if I can get paid?
Yeah, I think I have a couple things here.
Okay, perfect.
All right, let's go. So the equation for G. All right. All right, let's take a look. Oops. All right, so for G, right? The equation of a straight line can be given by y equal to mx plus c, right? Where m is the gradient and c is the y-intercept. Now, do we have either of those things given to us in diagram? Right. We had to find the gradient, right? But we also have the x-intercept. Yeah, man, no problem. Right? So we could actually use those coordinates, right? So the y is 0 and minus 6. And then the x-intercept is no. What stupidness are talking? Yeah. I did it again though. So the minus 6 is the x-intercept. Wow. Sorry guys, my brain real tired tonight. Yeah, had a bit of a rough night with the kids last night into this morning, got up, went to bed a little late, got up a little too early. Yeah. Right, yeah. So sorry, this is the y-intercept here. Well, it lined up quite nicely. Yeah. So we have x1, y1, and then x2, y2. Right, so let's find the gradient, right? So gradient is equal to the change in x divided by the change in y. So change in y divided by change in x. I clearly run out of steam. Okay, so we're gonna have 3 minus 0 divided by 0 minus 6. Now please note it is minus 6. So 3 minus 0 is 3. 0 minus 6 becomes 0 plus 6. And 0 plus 6 is just 6. And 3 over 6 will simplify to a half. Okay. So that's that. And therefore, the equation would be y is equal to a half x plus 3. Nice. Okay. What about the equation that represents line H? So with H now, again, we're going to be using what? Y equal to mx plus c, right? But the problem we have here is we only have 1 point for that green line, and it's the x-intercept, not the y. So we don't even have the y-intercept. And on top of that, if we only have 1 point, how are we going to find the gradient? Well, that's where this piece in yellow comes into play. If we know that two lines are perpendicular, the product of their gradients is -1. So if we know that, hold on, so let me zoom in here, right? So we know that the gradient of, hold on, sorry, the pink line is G. Okay, so the gradient of G multiplied by the gradient of H is equal to -1. Now we're looking for the gradient of H, and we have the gradient of G. So all we have to do is divide. Right? So that's equal to -1 divided by that gradient. Right? So that's equal to -1 divided by a half. So of course, when we are dividing fractions with the protocol, we change divide to multiply and invert the divisor. So we're going to get -2 there. Right. Now, How do we find that value of C? Well, this is the kind of regular and longer way, right? Now we only have one point along that line, which is 4, 0, right? So we could say using coordinates of 4, 0, right? Which is of course x, y, and this is m, in conjunction with y is equal to m by x plus c, right? So y is 0, m is minus 2, x is 4, minus 2 by 4 is minus 8. And of course, all we have to do solve for c is quote-unquote add 8 to both sides of the equation. And there you go. Therefore, the equation of h, y is equal to minus 2x plus 8. Right, and that's the usual way we have to find the y-intercept, sorry. Normally, they don't give it to us on the graphs, but they've been doing that, as you could see, a lot. So they took a tack back and they say, hey, let me take that out and see if they still know what to do. So you had to be prepared for any eventuality. All right. Donovan and D'Angelo, are you all okay with this stuff in the green? I know it's kind of a lot. Just give me a quick G. Right, I'm going to finish the question and then call it a day, right? All right. So we have one more thing to do. The coordinates of P show all working. What is P? P is the point of intersection of the two lines. So we have to solve this simultaneously. So what's the equation of G? Y is equal to half x plus 3. Okay, cool. So for G, you have y is equal to a half x plus 3. And for H, it was y is equal to what? Minus 2x plus 8? Right. Yemini, talk to me. What's this area? Do you have a question? I'll finish this one and then answer your question, right? Right, so what we could do is we could subtract. Y minus y will give us 0. A half x minus minus 2 becomes a half x plus 2x. So that's going to give us 2.5x. And 3 minus 8 is minus 5. Right? So what we do now is we'll carry across the minus 5. Or we'll add 5 to both sides of the equation. And then we'll divide by 2.5. 5 divided by 2.5 is actually equal to 2. Right? And if x is equal to 2, to find y, we can plug it back in the first one. So a half of 2 is 1. 1 plus 3 is 4. Right? So the coordinates of P are simply 2 and 4. Now, if you want to cross-check it, you could plug it into minus 2x plus 8. Minus 2 by 2 is minus 4, and minus 4 plus 8 is also 4. All right. So, folks, we're going to put a pin in it there for today. I'm going to pick back up on Monday. I might switch topics on Monday, but we still have more of this to do, but we have a lot more on the syllabus to cover as well. Well, in revision. Okay, I'll see you Monday, right? Okay, later. All right. Okay, so on Monday, just give me a quick G figure with the last part you do here, please, and that. All right, cool. All right, so guys, we'll pick back up on Monday. Like I said, right, classes. Classes for April stay the same. Oh, thank you, Mandy. Right. Right. So we are here. Wednesday, 2nd April. We have no more class this week. Right. For next week, Monday and Wednesday, as you can see in the blue there. Yeah, man. No problem. Happy to help. Right. The following week is where Easter starts. Right. So we stay the same day, Monday and Wednesday, 6:30 to 8:30. Right. But some long days for me, boy. Yeah. And then what you call it here, boy? Yeah, the next week we have no class Easter Monday, but we have class Wednesday. The following week, all right, Niall, I'll see you next week. The following week, when school starts back, we have class on the Monday, even though it's elections, 6:30 to 8:30, class on the Wednesday. I'll see if I can push for a class for Tuesday, but I can't promise that one. And then after that, we crash in POA right up until the exam. And then after the POA exam, from the Tuesday till the Thursday evening, we jam in maths. Yeah, man, Christian, no problem. And then we'll talk about the multiple choice after that time. All right, cool. All right, I'll see you tomorrow for. You have anybody tomorrow? You have your class coming tomorrow? You have their contacts? Okay, all right. All right, message me who you have or who you do have, and I'll send you the rest. But I'll match for sure. Okay. Right? You coming here to do it or you doing home?
Well, if I have class here tomorrow, then I'll come
Cool.
down, but if not,
Okay, cool. Yeah.
okay, cool. So
Yeah, message. Yeah, Kip Kimura was asking for sure.
Yes. I know she asked. I know you also said Josiah.
Right. Oh, shucks. We're gonna talk about him. Didn't get a chance to do that.
Oh, right. Yes. But I'm in anything that I can just come down.
Yeah. Okay.
Just do
Cool.
it then. So I'll message you.
All right. Cool. Sounds good.
See ya.
All right, guys. Later. All right. Yeah, guys. So yeah, and then the last day is the 6th of June. So we'll probably do multiple choice that whole week. Anyhow, guys, have a good evening. I'll see you guys next time. Bye.